Hello everyone, today we are going to see what are ideal reactors. This is very important topic for your GATE examination. Okay, so ideal reactors are chemical or biological reactors in which chemical or biological reactions takes place with the condition of no mixing or complete mixing in the reactor. So ideal reactors represent extremes in the mixing state. Then example for no mixing condition is plug flow reactor, and example for complete mixing condition is batch reactor and continuous stirred tank reactor or mixed flow reactor. Okay, in batch reactor and continuous stirred flow reactor, the reactor has agitator for complete mixing. So this complete mixing is to maintain a uniform composition throughout the reactor. Okay, the next condition is residence time. Residence time in the reactor should be same for all the elements of fluid. Okay, that means the time spent by the reactant or product inside the reactor should be same. Okay, then ideal reactors are relatively easy to treat and it represents the best way of contacting the reactants, and we can derive the performance equation for ideal reactors. So what is performance equation? Performance equation is nothing but it is a mathematical expression which describes the process inside the reactor exactly. Okay, this performance equation relates input and output of your reactor, then contacting pattern of your reactants, then kinetics of the reaction. Okay, then the general form of your performance equation is output of your reactor is function of input, kinetics and contacting pattern. Okay, here kinetics tell us how fast the reaction happen inside the reaction. That is, it will give the rate of the reaction. Okay, then before going to design a reactor, first you should know the rate of the reaction. That is, you should study the kinetics of the reaction. Then only you will go for a reactor design. Okay, then contacting pattern. Okay, so in general ideal reactors we have two contacting pattern. One is batch wise, then continuous flow. Okay, so batch reactor is example for batch wise process, and mixed flow reactor, then plug flow reactor is example for continuous flow. Then with this performance expression we can compare different designs. Okay, that is batch or mixed flow reactor or plug flow reactor, and we can find which is best for our given job and then scale up to larger units. Okay, but real reactors are not 100% ideals. Then why we have to study about ideal reactors? Why? Because ideal reactors are model for real reactors. Okay, real reactors are not 100% behave as ideals. Okay, then we often try to design real reactors approach these ideal reactors as closely as possible. Okay, then we come to types of ideal reactors. Ideal reactors have three ideal flow or contacting pattern. Based on these, we can classify ideal reactors into three types. Okay, they are batch reactor, mixed flow reactor and plug flow reactor. We will see about all these three types of reactors. First we will see about batch reactor. This is your batch reactor. This batch reactor consists of vertical cylinder or vessel. It is equipped with an agitator or stirrer for mixing the content, because we have to maintain a uniform composition throughout the reactor. The reactants are initially charged into a container and are well mixed and are left to react for certain period of time. Then the resultant mixture is discharged from the reactor. Okay, and in the batch reactor, during the course of reaction there is no fluid entering or leaving the reactor. This is an unsteady state operation where composition changes with time. For example, consider the following data. This table shows how the concentration of your reactant varies with respect to time. So at time t is equal to 0, your concentration is 2.77, and at time is equal to 18 minutes, your concentration is 2.32, and at 30, 2.05, and at 50 minutes, your concentration is 1.59. Okay, so here composition is changing with respect to time. Okay, so this is known as unsteady state operation. Okay, however, at any instant of time, the composition throughout the reactor is uniform. Okay. The next advantages of batch reactor, it is simple in construction, then easy to operate, and then it has flexibility of operation. Okay, that means it may be shut down easily and quickly. Then it has a very small instrumentation cost. Then it can give high conversion, but you have to leave the reactant in the reactor for long periods of time. Disadvantages of batch reactor, high labor and handling cost. Okay. It requires considerable shutdown time, okay, for empty the product and clean out the reactor and refill the reactant once again, okay, for the next batch. Then you have a poor quality control of product in the batch reactor. Then large scale production is difficult in the batch reactor. So because you need a very big reactor for large scale production. So it is economically not feasible. So for large scale production, we are going for mixed flow reactor or plug flow reactor. We are going for continuous system for large scale production. We will see about mixed flow reactor. Like batch reactor, mixed flow reactor also consists of a vertical cylinder equipped with an agitator for mixing the contents. Okay. Then in this reactor, reactants are introduced. Okay, reactants are introduced and product mixture is withdrawn from the reactor simultaneously in a continuous manner. So this reactor is known as steady state flow reactor. And in mixed flow reactor, the contents are well stirred and uniform composition is maintained throughout the reactor. So this reactor is ideal mixed flow reactor. Next, the condition for mixed flow reactor is the exit stream from the reactor has the same composition as the fluid within the reactor. So see here, initial concentration is your Ca0 and initial conversion is Xa0, that is equal to 0, and the final concentration is CaF, that is equal to Ca, and final conversion is Xa. So the exit stream from the reactor has the same composition as the fluid within the reactor. That is, in mixed flow reactor, the concentration of reactant, okay, so your initial concentration drops immediately to a low value. That is, once the reactant enter into the reactor, it immediately converted into product. So you will get your desired conversion. Okay, that is the condition for mixed flow reactor. The other names of mixed flow reactor are batch mix reactor, ideal stir tank reactor, the CSTR, CSTR, that is continuous stir tank reactor, or the CFSTR, that means constant flow stir tank reactor. Next we will see about plug flow reactor. So this is your plug flow reactor. It consists essentially of single continuous long tube or several tubes arranged in parallel. Okay, here the reactants enter at one end and product mixture leaves from the other end with continuous variation of composition of reaction mixture in between. Okay, so there will be a variation in your composition along the length of your tube. Okay, like CSTR, plug flow reactor is also an ideal steady state flow reactor. So in this reactor, the flow of fluid through the reactor is orderly with no element of fluid overtaking or mixing with any other element ahead or behind. Okay, so along the length of the tube there is no mixing. Okay, there may be lateral mixing of fluid in a plug flow reactor. That is, along in this way there will be a mixing. This is known as lateral mixing. So there will be a lateral mixing of fluid in a plug flow reactor and there is no overtaking or mixing ahead or behind. Okay, this is the condition for plug flow reactor. This type of flow is known as plug flow and the reactor is known as plug flow reactor. And the necessary and sufficient condition for plug flow reactor is the residence time of your reactant in the reactor to be same for all elements. Okay, the other names of plug flow reactor are slug flow reactor, piston flow reactor, ideal tubular reactor, and unmixed flow reactor. Okay, let's see a quick comparison between batch reactor, CSTR, and PFR. Okay, so in batch reactor, your composition is a function of time. That is, with respect to time, your composition is changing. During the course of reaction, there is no fluid entering or leaving the reactor. So it is a closed system and this process is an unsteady state operation. Okay, in both CSTR and PFR, your feed is entering and leaving the reactor in a continuous manner. So this process is known as steady state operation of continuous flow reactor. Okay, then in CSTR you have a condition that exit stream has the same composition as the fluid within the reactor. Whereas in batch reactor, your composition is changing with respect to time. Okay, in PFR your composition is a function of location, that is along the tube length your composition is varying. Okay, here the flow of fluid through the reactor is orderly. Okay, and no element of fluid overtaking or mixing with any other element of fluid ahead or behind. Okay, there is no mixing along the tube length. Okay, there might be lateral mixing of fluid in the reactor. In batch reactor your composition is function of time, and in plug flow reactor your composition is function of location, and in continuous stir tank reactor you should have the composition same both in exit stream and inside the within the reactor. Okay, thank you.